Gents, the following. Shh. They say it's parallel, and what I'm looking for is X, Z's, X, and F's. Does anybody see an F I could use? Anybody see sort of like a backwards looking F? Which one do you see? I think that's 70. Do you? Does anybody see the F I'm talking about? If you don't, here it is. There it is. Look, it's a weird looking F. Do you see it? Otherwise known as corresponding. No, no, no. Okay. Do you see it? If I was to rotate that around, mirror image, it's an F. Okay, gents, that is 70. Now we're in business. Because look, 70 plus 5x, where am I getting 5x from? 2x and a 3x. 70 plus 5x is 180. This implies that the 5x must be responsible for 110. Because 110 plus 70 is 180. If you really want to bring the 70 over and take it away, okay, divide 110 by 5. What you get? 22. Love working here. All right. 2 times 22. 44 and 2. It just asks us to find x, does it? I'll find the value of x. I don't even need to find that. 22. Happy days. Okay. Let's move on to the next one. Oh, is there a part B to that? Oh, there it is. Oh, lovely. All right. Yeah. Lads, will you call me out the numbers for the next one? All right. So, Alex, will you tell me what A is, or do we have it? A to E. C part B. C part B. A is 100, yeah. AC is 130. What does that mean about EC then? 30. Okay, keep going. DE is 74. The whole goal of the question is to find out the value of B to C. Is that okay with you guys? Sorry for those of you that are still taking down the other one. This here, that here was 70. And then 5x was responsible for 110. So it's just like 5x equals 110. And then you just divide 110 divided by 5. This is for part B now. I'm on part B now. I need the diagram to do part B. So you see part B, if you look at question B, lads, you make sure you're on the correct page and you're taking down notes here. All right, I'm doing part B. All these measurements I put on the board are all given to you in part B. Does everybody see that? Okay, now we're going to do a big triangle, small triangle. The best way to do this. Okay, so you write down a diagram with the big triangle and you write down a diagram with the small triangle. It should work nicely. They're both similar triangles, aren't they? What do similar triangles mean? Same shape, but same shape, different size. Okay, or just same shape, to be honest, same shape. Right? Now, okay, would everybody say that that's 100? Would everybody say that's 130? Would everybody say that that's 74? And what's the goal of the question? Call that X, is that okay? Actually, no, X already in use. Use a different letter. D or L. I'll go D. Okay? Small d. All right. Lads, we're going to play again with big triangle over small triangle. Big divided by small. Okay, gents. Pick two sides that are the same. 130 and 100. What's 130 divided by 100? 1.3. Big triangle is 1.3 times the size of the small triangle. Get your 74, multiply it by your 1.3. This is part B. Please take down notes. 96.2. Yes? Lads, 96.2, the radio station. Okay, gents, we're on to this one here. This one here is also similar triangles, isn't it? It's big triangle, small triangle again, I believe. All right. So, explain how these measurements can be used to find ED. Now, do you know what I would do first? Instead of explaining it first, I'd actually find it first and then explain how he did it. Do you get what I'm saying? I'm going to do the question first and then explain what he did afterwards. No, I think that'd be the answer to part two. So, lads, I'm technically answering part two first. Is that okay? So, all this here doesn't matter. I'm actually answering part two, okay? So, yeah, just want to get rid of that for a second, all right? So, I'm going to answer part two. Just feels weird to like not do the question. Okay, so I'm doing part two first, okay? What is A to E? 120. What's B to E? 80. C to D? 200. All right, this should be easy enough. We're going to do big triangle, small triangle again. Yeah, you know that you know the story already. Okay, for somebody like me, I actually find geometry quite tough, even as a teacher. So I always have to draw them out. So I'm relating the 200 to the 80. Ever see that? And when you divide, you do big over small. And what does that come out as? 2.5, yeah? All right. Everybody cool, 2.5? Okay. Now, that's 2.5, which is 2.5 times bigger. Now, does everybody see E to D? E to D would be actually this big old length here. Ever see that one? That's that yellow length here. All right. And that yellow length is 2.5 times bigger than 120. So you get your 120 and you multiply by 300. 300 for the full thing. And what does that mean about E to D? No. Look at it. 180. Because 120 plus 180 is 300. Pause it there. If you're explaining what you did, it's like this. You identified two triangles as similar. You identified a big triangle and a small triangle. You found out the ratio by dividing the big triangle's length by the corresponding small triangle's length. This proved that the big triangle was 2.5 times bigger. You then figured out what the length AD was by multiplying the length AE by 2.5. Then you subtracted the length of AE from AD to find out that ED was 180. It's a game of a big triangle, small triangle, all right? Similar triangles are pretty much all about this. Now, it's safe to say that this blue angle is the same as this blue angle, and this red angle is the same as this red angle. Okay, in between red and black is 25. This means the 25 is corresponding to the 15. Everybody cool with that? We then do 25 divided by 15. Do not do decimals, they're the devil. It's 5/3. The big triangle is 5/3 times bigger than the small triangle. Okay? Now, 6, you're going to multiply 6 by 5/3. You need to get a bigger answer than 6. Why? Because the triangle's bigger. So you're going to multiply 6 by 5/3, and what you get? Who got 10? Yeah. It's 10 on the money. Did you use decimal around it? Yeah, be careful with decimals. Use fractions, more accurate. Yes. Why in the previous question did I use a decimal? The reason in the previous question why I used a decimal was that's a clean decimal. The decimal you guys are using is 1.6 with a dot above it, which means 1.6666, and then it round off to 7. So you'll have to round it to 1.67 or 1.7, which introduces a rounding error, which is why in this case we chose to use the fraction. Is that right? So if you ever see a dot above the 6, it means you should probably use the fraction, not the decimal. Yes. Yeah. All right. Everybody cool with that? That was handy. Oh, we're done. Is that it? Oh, is there? I know. Now, lads, this is what's known as a cyclic quadrilateral. Can anybody tell me what is a cyclic quadrilateral? What's a quadrilateral quad? What's a quad bike? Four. Quadrilateral is a four-sided object. Everybody taking notes? It's a four-sided object. A cyclic quadrilateral, there's a special rule in a cyclic quadrilateral. The special rule is the following. Opposite sides have to add to 180. So what does that make x outright? 80. Okay. Now, because it doesn't give me d, oh, I'll read the question. There might be more information. Calculate the value of x. 80. Done. Okay. Now let's go up. Let's go to the next part then. Calculate the value of y. Show all your workings out. Okay. It's specified that we need to show all the workings. Okay. Now this is going to be interesting. All right. Does it say anything about a diameter or anything in this question? What else does it say? Yeah. Have no idea. Okay, have no idea. Anybody else have an idea? Uh, I was actually going to go for a B to D. No, it's not a semicircle. I guarantee it's not a semicircle. It's not a semicircle. It looks like it specifies that it's not. Look, it's not 90 degrees. It specifies that it's 100 degrees. That's how you know it's definitely not a semicircle. That would be 90 degrees if that was a semicircle. Okay. Now here's the trick. What type of triangle is the yellow one? Huh? The yellow one is isosceles. Okay. That means that this angle here, angle M for argument's sake, is the same as this one here. How much degrees am I short? 80, haven't I? Shared on each one. So what you're going to have to write this is 180 take away 100 is 80. Right? And then you say 2m equals 80, or just divided by 2. M equals 40. 40, 40. You're going to do the same thing for the blue triangle. Okay, we got it? Think of another letter, N. Is that all right with you guys? We're going to do exactly the same thing. We're going to do 180 take away 80, which is 100 divided by 2n equals 100, and then n equals 50. Then you have your two 50s. Okay, and what angle does it want from you again? Y. Now, do you notice that y is the 40 and the 50? So y is 40 and the 50, so y actually equals 90. Now, that actually means that A to C is the diameter. You're correct, but you had no way of knowing it. You didn't know that was 90, and it didn't say. So you wouldn't be allowed to just assume it's 90. Assume it's that. Huh? Yeah, exactly. You can't assume it. You've proved it. So see the way I proved it without actually using it? That's it. No, they're not parallel though. They're the same length. They're isosceles, and that's exactly what I did use. I used two isosceles triangles. Uh, means the yellow line equals the yellow line, and the blue line equals the blue line. That means they're both isosceles. We cool? Is there anything else to that question? No. Okay, cool. All right, I didn't actually copy the next question, but I'm sure I can do it. Converse of a theorem, is it? So what did we write down yesterday as a converse of a theorem? All right, I'll find it. was formed by swapping the hypothesis of the order of the hypothesis and the conclusion. Oh, for God's sake, my language is it. Converse term. Okay, just ask me to give an example in the next one. Does it want an example that's true or false? State one that's true and one that's false. You ready? Okay. What's the one we said we'd keep in our armory that we'll use every time? Huh? God, is that all right? In a isosceles triangle, the angles opposite the same length size are the same size. Okay? Now, and then what's the opposite of that? We want to move isosceles to the end. Remember, see the way isosceles is at the start? We want to move isosceles to the end. So if in a triangle, two angles are the same size, then this triangle is, you can put that in as well. Two lengths, the same length. But I think the conclusion was that the angles are the same size. So we're starting off with angles. Triangle, two angles are the same size, then this triangle is isosceles. Okay, and then finally, do you remember the fake one? All squares, all squares are rectangles, but not all rectangles are squares. There's a converse that's false. All squares are rectangles, but not all rectangles are squares. There's one where it's false. All right, gents, we are for tonight.